I want to discuss the effect that multiplying variables in an equation has on the outcome of that equation. This is a concept I'm going to call the multiplier principle. And the essential idea of this multiplier principle is that by changing one variable, you can predict what will happen to another variable in this equation. To demonstrate this, I'm going to use an equation we haven't worked with yet. Centripetal acceleration is equal to velocity squared divided by radius. This is an equation that's on your reference table and we're going to work with soon. But what's important to notice now is a couple of things. First of all, there's a numerator. The variable in the numerator is squared, and there's a denominator. And the variable in the denominator is not squared. So I'm going to define these values: centripetal acceleration, I'll just call it acceleration for this video, velocity, and distance, or radius. Let's look at how doubling the velocity affects our acceleration. So I want to look at a situation here, and I want to see how doubling the velocity affects our acceleration. I'm going to show it with real numbers first. So let's say, for example, we had a real velocity. We'll say our velocity is 5 meters per second. And we have a real distance, and we'll say this distance is 2 meters. And we want to know our centripetal acceleration. And we calculate it, and you get 25 over 2, which is 12.5. And now let's say we double our velocity while keeping everything else the same. What's our centripetal acceleration now? Now we have 10 meters per second, which gets squared, divided by our same radius of 2 meters. And what do we get here? When we work through this, well, we get 10 squared, which is going to equal 100, divided by 2. We're going to get a centripetal acceleration, which is 100 over 2, which is 50 meters per second squared. So what happened to our acceleration here when we doubled our velocity? Well, it went from 12.5 to 50. So our acceleration was multiplied by 4, even though all we did to our velocity was multiply it by 2. And the question is, well, how did that happen? And how can we predict that? And here's what you need to look out for. First of all, does our variable have an exponent? If our variable has an exponent, you must apply that exponent to the multiplication. So for example, if we double our velocity, that velocity has an exponent. It's squared. What is 2 squared? It's 4. And that's where we get this times 4 from. Doubling the velocity, which happens to be squared. So our first rule here is going to be apply exponents. If your variable has an exponent, apply it to that multiplier. The second thing we want to look for, is it in the numerator or denominator? If it's in the numerator, you're going to multiply your result. So if we take a look here at velocity, it's in the numerator. So it multiplies directly to the other side. And that's why centripetal acceleration was multiplied by 4. So if it's in the numerator, multiply. What if it's in the denominator across the equal side? Well, let's look at that scenario. And let's use our same rules. So we're going to get rid of all of this. And let's apply a rule here. And let's say, well, what happens when we change our denominator? So I'm going to go back to our original situation. Our centripetal acceleration was v squared over r, which I made 5 squared divided by 2. And that gave us, if you will remember, 12.5. What happens if we change our denominator? What happens if we triple? Actually, I'm just going to double it. Sorry, let's just double our denominator. So new centripetal acceleration, 5 squared divided by double 2, which is 4. And what do we get now? We're going to get 25 divided by 4, which is 6.25. So here, what happened? We doubled our radius. We divided our answer by 2. If it's in the denominator, you would divide. So if we look here, another example, let's say I multiply our radius by 3. Well, that would divide centripetal acceleration by 3. Notice there's no exponent here, so we don't have to worry about applying exponents. But when we're multiplying variables, apply exponents. If it's in the numerator, multiply. If it's in the denominator, divide. That's our rule. Let's look at a more complicated situation like this. And let's use the same equation. And let's say I multiply velocity by 3 and radius by 2. What happens to centripetal acceleration? Well, centripetal acceleration is v squared over r. We multiply velocity by 3. We multiply radius by 2. The 3 is squared because we apply exponents. It's in the numerator, so we multiply by 9. In the denominator, the 2, no exponent, and it's in the denominator, so divide. The AC is multiplied by 9 over 2. If it was 10, now it's 45. You multiply by 9 over 2. So it would go, let's say, from 10 to 45, because that's times 9 over 2. Let's continue with this idea one more step. What if you have a fraction in your denominator? Well, if you have a fraction in your denominator, nothing really changes. You still apply these rules, but it looks a little different. Like, let's say we divide our radius by 3. So I'm multiplying this by 1/3. Remember your rules for dividing with fractions. Keep, change, flip. We are going to divide both sides by 1/3. What is that the same as doing? Well, we have centripetal acceleration divided by 1/3, which is the same as centripetal acceleration times 3 over 1. So we get 3 times our centripetal acceleration if we divide our radius by 3. So a fraction in the denominator, you divide by that fraction, which results in multiplication. That brings us to a problem like this. If the distance between two objects is doubled, what happens to the gravitational force between the objects? Well, how do we calculate gravitational force? Gravitational force is G m1 m2 over r squared. What did we change? We doubled our distance. So we're going to take our distance here and multiply it by 2. Question is, what happens to the gravitational force? Well, first we apply exponents. 2 squared is 4, and it's in the denominator. So we divide. So what happens to our gravitational force? It is quartered. It is divided by 4. If the gravitational force was originally 100 newtons, well, now it's 25 newtons. We are dividing it by 4. That is the multiplier principle, and it applies to every equation. It's more of a math concept than a physics concept, and I certainly hope that makes sense.